Okay, we have maybe a few more seconds to go until we start. Let's wait. Let's be precise. Okay. Hello, everyone, and welcome. We are Finester, and today's topic is how you can complete your composites with our fire protection coatings. My name is Ari Hokkanen. I'm the founder and the CTO of the company. My background is in composites. I've been doing composites since my childhood, and I'm here with my colleague Trevor.
Good afternoon, everybody.
And today the topic really is the fire protection coatings. So a few words about Finester. We are SME backed by investors located in Lahti, 1 hour from Helsinki, quite nicely located. And our focus is fire protection coatings for composites. We manufacture, we supply, and we deliver coatings. Everything is in-house technology based on innovative ceramification technology and more or less controlled intumescent technology. Ceramification is the technology where polymeric material will turn to ceramic material when exposed to fire, and intumescence is a property when the polymeric material starts to expand rapidly when exposed to fire. Also, we have fire retardant treatments for natural fibers. What do we see as a fire challenge in composite market? Well, everybody in the audience knows that the composites are great materials. They are used as a last resort when other materials fail. And the benefits of the composites are that they are lightweight, they are very strong, and strength to weight ratio is unbeatable. They have very nice consistent quality. We can produce very nice small series with consistent quality. And you can have nice appearance, different colors. You can have different gloss levels, textures. You can use them outdoors. They never corrode. Low maintenance required. And they can be processed in different shapes with inexpensive tools. But let's face it, they are oil-based and they burn. That's the Achilles heel of the composites. Of course, there are fire retardant or fire resistant composites in the market, but they are more or less done with adding some fillers into the resins, some additives to the resins, or even change to specialty resins. But they usually lead to compromises in the composite. And you will lose the properties why the composite was chosen in the first place. So suddenly they are heavy, not that strong, they are brittle, not consistent. You have limited colors available, gloss levels available. You really cannot use them outdoors because they absorb water and they cannot handle UV. They are high viscosity resins, high viscosity products. It's difficult to process. But yes, you will get some fire protection at some point. But you will lose that nice properties of the composite way it was originally chosen from, and that's chosen for. And it's like using the same tea bag for 5 times. You are technically still drinking tea, but it's not very good tea. These are technically, they are composites, but they are not very good composites. So our solution is fire protective coatings, and they go under the trade name of Finester Red. So you keep your composite as it is, don't change your composite, you just coat it or paint it with our fire protective red coatings. And there's no need to change your composite, just add that missing fire element by using our coatings. So how red works? Let's see a 15-second video. Okay, let's watch that again. So again, this is a standard composite at room temperature. This is an epoxy glass fiber composite without any additives, but it has two-layer coating on top of it. So it has a base intumescent base layer, pure red layer, and then it has a top coat, hybrid red top coat as a ceramifying layer on top. It's in blue color, and it has some water droplets for creating the effect. And now what happens next is the Bunsen burner is introduced from the right side. It's a bit not too much visible, but it's still there. And the surface temperature starts to increase rapidly. Okay, maybe it's not the best image for the pause, but you can see under the play mark there is a, maybe I cannot remove it, but what happens next? The organic material burns away. So there's some organic material, hence the name, hybrid, inorganic, organic. So the organic material burns away, and that's completely okay. At the same time, let's watch it further like this. About this stage, about 700 degrees, all the organic materials are gone, and inorganics are left, and the ceramification process starts to begin, or is already in process. At the same time, the heat will transfer to the other side of the ceramified coating to pure red layer, and that starts to expand. So that's our intumescent layer, bottom layer that starts to expand and creates this kind of ceramic bubble. Here we go again. Organic burns away, ceramic bubble is formed, and ceramification is complete. And this is now stable. You can burn it, hours and hours in 1,000 degrees, and that's stable. And that stable bubble, that stable ceramic bubble, will isolate the heat from the composite itself. So the heat will never go to the composite, and that's why you can have that standard composite in your process. Maybe watch it once more. It's a bit clumsy, the user interface. Without the ceramic bubble on top, the intumescent would just keep expanding and eventually will fall on the floor and expose the original composite. But in this case, it's closed in a ceramic shield bubble. Okay. So again, in a nutshell, standard composite at room temperature, Bunsen burner introduced to the surface, starts to increase the temperature rapidly, the organic materials burns away. This is completely okay. These are not incombustible systems, these are fire protected systems. And then ceramification has happened, and all the organics are gone. You can see this gray silvery area here, and that's a ceramic material. And then it stabilizes after 1,000 degrees and keeps the stable fire protection. Okay, so now Trevor will continue.
Thank you, Avi. I see from the chat that some people are having problems seeing the presentation, so apologies for that. Hopefully you can get in touch with us afterwards and we can share the presentation with you. So why coatings? Why do we think coatings are the answer for fire protection? A great number of reasons. As you can see with the photos here, we have the choice of different colors, gloss levels. These coatings are very easy to apply. They're spray applied usually to get the best control of film weight and final appearance. You can build up the coating under a number of layers, but also you can also fix any defects to your composite substrate. So the bottom left photo in the slide you're seeing at the moment shows some severe wetting problems with the gel coat, and you can put coatings on that and basically fix your problem. So as we look at coatings, we have a number of benefits to our technology. As we mentioned before, yes, the poor composite surface is a big benefit, repairing what is not a perfect finish. The flexibility of the production. Of course, with coatings, you can also take an existing coating off and put another one on in service. So maintenance and the extending the life of materials that are already out in the field, whether out on an oil platform, for example. And really, our technology is summarized by the all-in-one phrase. You're getting the colors, the surface effects, you're getting outdoor weathering, UV light resistance, and also wear and tear resistance, scratch, anti-graffiti, and giving us this confident and consistent fire protection properties. As I mentioned earlier, we prefer recommending a spray application, but you can also apply our red technology with a brush or roller as well. Another benefit is that this technology will cure at room temperature. So obviously, if you have big pieces, if you're manufacturing composite bridges in one piece, for example, or large panels that don't fit into ovens, then this technology is ideal for that application because you can allow it just to leave it and allow it to cure at room temperature. We found that it's also quite compatible with some composite processes. At the moment, filament winding is quite an interesting topic for us. We have a commercial business where the coating has been incorporated into the existing filament winding production process, coating individual items, and also we're finding that we can work with both thermosets and thermoplastics. So it's not a case of just sticking to perhaps an epoxy glass fiber composite or polyester glass fiber. It's very broad in its application, this technology. Unsurprisingly, I think for most of you on this webinar today would be the number of markets where you find composites is basically the number of markets where we think our technology would lend a benefit. So certainly in the transport, the aerospace, the automotive, traditional transport industries for composite applications, and also in the new, if we say new energy, so the battery casings and pressure vessels to power the vehicles of the future, but also in the construction industry. So very much with building products, with commercial, with the red technology in certain construction applications. So building products, railway vehicles, and also railway infrastructure, and for general infrastructure applications. A little bit of a case study here. So one of the good examples of how our product really has helped enable a business is this marine case study. The company here is a company called Norsa Power. They've developed and commercialized a new form of powering commercial shipping, this rotor sail technology, and this white funnel-like structure that you can see in the photograph is a rotor sail, and that's been coated with our Finesta red technology. That obviously requires not just the fire resistance to meet the standards, which in this case are the IMO 2010 FTP code standards, Part 5 and Part 2, but also it requires outdoor weather resistance, durability. This is out on the oceans, out in the shipping, so fairly severe outdoor requirements, and our coating is able to provide the protection needed for that application. Another application I mentioned earlier was the construction applications. When you're looking at different levels of performance in the construction world, we're often referring to EN 13501-1 as a standard. And I'm pleased to say that in combination with, in this case, so it's polyester glass fiber composite materials, we're able to achieve a Class B S1D0 for the full classification, which is pretty much the best you can expect from composite materials. For those of you who are aware of this EN 13501 standard, the A1 and A2 classes are really for non-combustible materials, which composites will not be able to meet in their own right. So we're pretty much top of the level in terms of performance for fire in the construction standard. And I should point out here the total heat release that we achieved is a very good result, less than 1.5, so well below the threshold required for that B classification. Also, we've done some work in the aerospace world. So we've managed to develop a two-coat system, in this case for aircraft seats. And this two-coat system has passed some quite stringent 25853 standard tests, the flammability and the smoke tests, which are always quite a challenge to meet. And with our two-coat system, we are able to meet that requirement. And as you can see from the picture, it's an aluminized finish on this occasion. But as we said earlier, any color is possible.
So it's black.
And a little bit more about our capabilities. We can't really do our work without having a degree of access to FAR testing. I'm pleased to say that Finesta took the step at the beginning of this year to invest in a new FAR test laboratory, a really important step for our business. It means we can do all the work in-house now. We can do the development of the coatings, we can run the test protocols, and we can see how our products are performing with different composites, seeing how their compatibility is. And in the picture, this is actually what's called a cone calorimeter. So this is a key test in the FAR world, measuring the heat release or the heat emission from a composite during a burn test up to 750 centigrade. So this is a really important piece of equipment and gives us a lot of detail, a lot of information on how our coatings are performing and protecting the composite underneath. And summarizing our capabilities in our FAR test laboratory is this little, I guess, sort of a hexagon flower diagram. So the heat release I mentioned earlier, the 5660 is the standard there with the cone calorimetry. But we also have test equipment available that we use to determine time to ignition, the flame spread, checking out burning droplets, and also we have a test rig to test and to look at thermal transfer, so effectively seeing what's potential structural failure when things are burning. We don't have the smoke and toxicity test equipment at the moment, but we hope to complete this picture in the coming months. And then just a couple of example slides of what sort of information we get out of our equipment. So this is the thermal insulation testing I mentioned a moment ago. And we think this is a pretty impressive result. We can keep temperatures on the unexposed face of a 3 millimeter thick thermoplastic glass fiber panel at around 200 centigrade, while the exterior is at 1000 centigrade for a 30-minute period. So this really shows, if you think back to the video that Ari showed earlier, that this thermal protection, this barrier protection is performing very well, and it's stabilizing. It keeps a flat profile on these temperatures. It reaches a steady state, and we are protecting a lot of the heat from getting through to the composite, and of course, therefore, protecting and preventing structural failure of the composite. So the graph on the left is very interesting, and also the graph on the right, which is more to do with the pressure vessel business, so thicker epoxy carbon fiber panels. And again, getting a stability there below 200 centigrade in terms of the performance of the system. And then one further graph we have is what we were talking about, consistency. A big problem particularly in the railway standards world, the EN 45545, is that you have a black and white threshold number that you have to get below to get to a certain classification. In this case, it's called a hazard level. And we're pleased to say that with coatings, you can really get very consistent results. You can get consistent readings. You can see those 3 readings on the left there within 1 or 2 units, kilowatts per square meter. And so coatings basically brings in consistency. You're not reliant on how the composite's been produced. You're not reliant on the slightly difference in the composition or the manufacturing process. The coating fixes it and gives a consistent and reliable heat release result. So now I think I'll pass back to Ali to complete our presentation.
Yeah, let's go through a bit. If the our red technology, red coatings is right for you. Well, short answer, we don't know. It's not that simple, but let's find it out. So, of course, we need to assess the viability of our technology, your process and your technology and your business. So meaning that of course, we can have a two-way, and we should have a two-way communication, but we can have a two-way NDA if required. Then we can have the communication, we can have the goal settings, and then we can have a commitment both ways. And then we can specify the technical issues. We can specify what kind of fire tests are needed to pass. Is there color requirements? What about gloss, textures? What's the substrate? The mechanical properties needed, adhesion, etc. Of course, there is a process also need to be integrated. How you do things today? Are you going to put it in continuous line? Are you going to do it on site? Is that what are the curing times, nozzle sizes, whatever? And then the business opportunity behind it. Is this a new business? Is this something you're going to replace? A timeline to the business and value proposition, and you know it. So when all these balloons are fully filled, then we can have the success in the middle, and that's both ways success. But what does it mean in practice? In practice, it means that let's discuss. Let's have that Teams meeting or Zoom meeting, and let's discuss about your technical requirements. Let's discuss about desired process you want to integrate it to, and let's discuss about the business opportunity behind it. And if we see that this is in a decent level, that we should continue working together, then you can send us your sample of your material, and we will do the compatibility tests and burning tests here, and then we can see that we have something that we can offer, and then we can analyze the results together and recommend next steps. And the last slide, just the conclusion. So there's no need for you to change your composite. That's just a normal standard without any FR composite that we are working with. And we will match our products to your application, your process, your business, because we can do that. This is not fixed, written in stone product. These are adjustable. Curing times, viscosities, you name it. And of course, the full fire test and guidance and support from our in-house laboratory. And new applications are very welcome. Thermoplastics, natural fibers, bio-based products. That's all in our radar. So in a nutshell, Finesta Red fire protection coatings completes composites. Okay, thank you for that. We have some 7 minutes for the questions and answers. I guess we have plenty of those. Can you, Trevor?
Yes, I can go through the questions with you, Ali. So the first question is, which thermoplastics could be used in combination with red technology?
We have quite extensive testing done with polyamides and then PLA. But we don't recommend polyolefins, of course. So PP, PE is out, and that's without any surface treatment. But polyamide is working very nicely. And what else do we have? PMMA, yeah.
Second question here is, how about delamination between the coating and the bulk material for mechanical applications? Is it possible to reduce the influence of the critical interface between them?
Well, that comes down to the compatibility and adhesion that we need to, when we know the substrate, then we'll match our base coat technology to get the best adhesion. So if it's epoxy-based or is it polyester-based, what is your substrate, then we'll match and that's why we need that sample to really test the adhesion before doing anything else. If there's no adhesion, there's no fire protection.
What is the VOC of your coating?
Very low. So these are not solvent-free totally, but these are very high solid systems. 2 component solvent-based, but the high solid system, so there's a 3% of solvent in the system. We can make it totally solvent-free, but then it requires a bit of the equipment.
One further question here, can this product reduce the blistering effect on colored coating of carbon fiber?
Blistering effect, it doesn't blister. So I didn't maybe fully understand.
No, I think it's to do with the adhesion and how things happen with carbon fiber. So have we seen? We've worked with carbon fiber.
Yeah.
We've got good results.
Or is it osmosis?
Yeah.
So it has very good osmosis resistance, and the red technology works beautifully. It's a high performance coating if you don't care about fire at all. So it's still a very nicely performing coating, but it has that added ceramification effect when the fire is involved.
At which temperature is the intumescence activated?
approximately 270.
Okay. Has the coating created foreign object debris when on fire, limiting your application in the aerospace sector?
No, it doesn't create any foreign object during the fire. It ceramifies and keeps everything intact in a capsule.
How does the coating behave under abrasive forces?
It has very good abrasion resistance compared to polyurethanes. Polyurethanes are kind of soft. These are hard but tough coatings. So the hybrid chemistry enables that combination from the organic inorganic world. So these are hard but tough, but not elastic. But they are more or less tough. So it has very nice abrasion resistance. We can give you, of course, more details. We have done tests, but we can go them through separately if you contact later.
Okay, we have a question on what is the price of 1 square meter coating, roughly?
Roughly?
Depends on the application.
Yeah, film thicknesses, 2 layers, 1 layer. So it's difficult to give any numbers here, but of course, please contact them, and we see the application, we see how many layers do you need, what is the thickness. But it will be, in a total price, will be cheaper than you have your FR composite with all that labor, all that time, all that equipment, all that waste. If you do that with the standard composite, you just paint it afterwards. Even the total cost is what matters here.
Okay, another question here. Is it compatible with other commercial paints?
You mean if you paint on top of this? Why you don't have to do that? It's compatible with everything if you sand the surface, expose the material, then you can paint it if you want. You can paint it, yes. But you should sand it carefully. These are very hydrophobic systems that might create some issues if it's not properly sanded.
Okay, here's a nice one for you, Ari. Do you know how behaves the intumescent char under vibrations? Can the char layer paint detach away the composite substrate when fired under vibrations?
That's a very good question, and this is why we have designed this 2-layer system. So if you have only intumescent layer, the char is more or less fluffy and light. So when you have vibration, it will fall on the floor. With this system, we have two separate layers. You have that ceramifying bubble that protects the intumescent foam underneath. So it's fully reliable under stresses and vibrations and airflows.
Okay. Any experience with ASTM E84 tests?
Do you remember?
I don't think we've done E84 yet. We've had some interests, but we've not done any specifics.
We've been following European standards, so this is American standard, so not too much.
How do you control the quality of products in production?
We have ISO 9001, 14001, and of course every batch is controlled in the right manner.
Do you have solution for SF6 gas protection on composite FRP tube?
Do we?
I don't know. I think we could do with a bit more detail on understanding that one.
This is not yes or no question.
It's not one that we've actually come across that one.
Of course we have. Please contact us.
Okay, that's all the questions that I just check if I missed any.
Gas permeability is.
Oh yes, there were some questions on the weights. So typically, what aerial weight is applied on a composite panel? So what film thickness?
400 plus 400 grams per square meter is the standard to begin. If you get very nice protections with 400 plus 400, 800 grams per square meter, which is approximately 600 microns, the film thickness, total film thickness.
But sometimes just a single coat application will do the job as well. So sometimes just a 250 micron, 200 micron of the
depending on
coat.
that, yeah. Depending on the what kind of elements do you need. If you need that, if you need only that flame spread time to ignition, one layer is enough. Burning droplets, 1 layer is enough. But then if you go to heat release and structural failure, you need 2 layers.
Maybe a final question: how to repair in case of chipping of coatings?
It's fully repairable. I mean, in any coating, there will be damage. There will be vandalism. There will be, some hits with the hammer. So these are not indestructible coatings. Of course, you need to repair them in case of damage, and you can repair just the sand it, mask it, and spray a new layer on it, and it will cure at room temperature. So it's repairable. That's it. I think we are running out of time. We still have half a minute, so we can wish everybody a very nice end of the week and
enjoy the rest of the event.
Yeah. Thanks.
Thank you.
Bye bye.